Good afternoon. Thank you, Eden. So let's do a 15-minute deep dive on Surfpool. Since I'm relatively new to the Solana ecosystem, I'm going to start with a quick intro. So I'm Ludo. I'm co-founder of Txtx. Previously, I co-wrote the V2 of the Txtx blockchain, the first Bitcoin L2. After launching that blockchain, I spent a few years leading Txtx DevX, while my co-founder Mikaya was a core maintainer of Ganache at Consensus. So we spent years building infra stuff in crypto, working closely with some of the most sophisticated teams in the space like Circle, Pith, Consensus, Eigenlayer, and many others. We've seen the common pain points firsthand, and we've been obsessed with solving them. By attending Accelerate, I'm assuming velocity matters to you, so I hope you'll appreciate what we've been cooking. Let's dive in. So with Surfpool, our mission is clear. We want to deliver the best developer experience possible for any developer joining crypto. And you'll see with this presentation that we are already pushing the boundaries. So what is Surfpool? At the surface, it's a massive upgrade of your Solana test validator built on top of Latest VM. But there's more. Surfpool brings powerful infrastructure as code tooling, the same tech that earned us the first prize at the Colosseum Radar Hackathon. So let's kick off this deep dive with the Solana simulation bits. As a developer, when I want to simulate my program, or say build a front end on top of a Solana program, I have a few network options available today. Let's start with the most accessible one, Localnet. So Localnet is usually spun up using the Solana test validator, either directly or through Anchor. It's closely mirroring the behavior of Solana Mainnet, and you can kill it, reset it, redeploy. The network lives entirely on your machine, and that's perfect. But in crypto, when you build, in most cases, your program doesn't live in a vacuum. It needs to interact with the rest of the world. It could be anything, other protocols like Pith or Drift, tokens like USDC, or infrastructure protocols like Squad or SNS. The biggest strength of Localnet, being a clean, isolated environment, is also its biggest weakness. Yes, you can inject data manually, but it's tedious and painful. And without meaningful data, it becomes almost impossible to conduct end-to-end simulations. So next, we have DevNet. DevNet is a free, decentralized network maintained by the community. It's public and it's persistent. It gets us closer to the Mainnet experience, and it's a wallet first-class citizen, which means you can do end-to-end simulations, connect, interact, and see results just like on Mainnet. But your program still needs to interact with the world, protocols, tokens, infrastructures. And on DevNet, that world might not exist the way you need it to. Every team treats DevNet differently. For a few, it's a clean, stable sandbox to help developers prep for Mainnet. But for most, it's a staging ground where things break, change, or disappear without notice. And finally, we have Mainnet, the real deal. In my experience, and in the eyes of every developer I've talked to, Mainnet testing is the gold standard. It's the closest you get to reality, and the best thing you can do to build confidence. Deploying on Mainnet is often a scary step. It costs real money, and mistakes are expensive. So because of this, teams usually wait until late in the development cycle to test on Mainnet. So if Mainnet testing is the gold standard, then the question becomes, how can we get Mainnet-like confidence without the cost, risk, or friction as early as possible in the development cycle? And that's where Surfpool comes in. So Surfpool is essentially Localnet plus Mainnet data. It runs locally, just like Solana Test Validator, but it can boot up instantly on a Raspberry Pi with real-world data that will present when you need them. So tokens, account protocols, everything you need. So you keep the speed and control of Localnet with the realism of Mainnet. So as I mentioned earlier, we want Surfpool to be the first developer touch point on Solana, and that comes with responsibility. As a dev, if you're giving Solana a spin, it's probably because you've heard it's fast. So we want to show you the Bugatti right away. We've built a simple TUI that makes this possible. It's not just fast, it's also didactic. It introduces concepts like slots and epochs, which are often new to developers. And to showcase Solana speed, we brought back a tiny feature that may taste like a Madeleine de Proust for many of you. Break Solana is back, baby. Smashing my keyboard and realizing that on this chain, I don't have to wait 12 seconds to get my transactions confirmed was my Solana aha moment. And I'm sure many can relate. Surfpool also gives you better fine-grained control over the chain. You can pause block production, send transactions, mine block manually, and step through state changes. Great for debugging and learning how things evolve over time. And finally, Surfpool runs with real mainnet data. So thanks to a copy on read strategy, your local environment automatically pulls from mainnet just in time whenever the execution layer needs it. No setup required. Having unlimited access to mainnet data is solving one problem, but we need something else, a way to bend the consensus rules to set the chain state in certain shapes. We are also introducing a series of cheat codes allowing you to do this. To illustrate how powerful these cheat codes are, we spent a few cycles solving a recurring Web3 issue, faucets. So faucets have always been a pain, unreliable, gated, and hard to work with. It's scattered over the ecosystem. If I need Sol, I need to go to the foundation. If I need USDC, I need to go to Circle, and so on. So we built a universal faucet powered by Surfpool cheat codes. You can fund any account with any token, and it's instant and local. The feature was incredibly straightforward to implement thanks to the unified token storage layout on Solana. And as a cherry on top, we are launching SurfNet as a service, perfect for teams. Spin up a shared network in the cloud, straight from your CLI. No setup, no friction, just collaboration. So that wraps up the simulation story. Now let's look at the other part of Surfpool. So Web3 has deeper issues we've been obsessed with. Let's dive in. Deployment and operations is something we are still not mastering at this point as an industry. If we compare the level of maturity between cloud infrastructure management and Web3 infrastructure, supposed to be our next money infrastructure, it feels like we are stuck in the 90s with bash scripts and one-off JavaScript files being the current standard. We're losing billions of dollars every year on DevSecOps hiccups and compromised private keys. We think we have a strong foundation to address this problem by introducing infrastructure as code to Web3. So let's dive into our design principles and first define what we mean by infrastructures. So we identify three big categories. So the first one is on-chain infrastructure. And by this, we mean all the transactions required to set up your protocols. So this includes the programs you wrote, but also the set of instructions you need to send for initializing your protocols. Then we have the signing infrastructure. What's being signed? Who will be signing? With what key? How can we help developers transitioning from low-friction key pairs on Localnet to high-safety multi-sig schemes on Mainnet? And finally, the off-chain infrastructure. So this is all the off-chain components your protocol requires: indexers, scheduled jobs, watchdogs, sentinels, and so on. These components need to be testable locally, and they need to be tightly coupled to your on-chain infrastructure deployments. So now the code part. So Web3 infrastructures are very sensitive since they involve key pairs, possibly controlling hundreds of millions of dollars. The code component needs to get a set of constraints. We wanted a declarative language, composable and static analysis friendly. And we should not have to execute the code to understand what the code is doing. So for all these reasons, we went with some sort of non-Turing complete subset of HCL, which is the language powering Terraform, as a first-class citizen. And we're calling these declarative programs Web3 runbooks. When writing a runbook, you're basically describing a workflow of transactions. A simple static analysis helps us make sure that these workflows are direct acyclic graph. And another property that we want is something we call stateful execution. So if you execute the graph once and re-execute it moments later with unchanged input, the execution should be a no-op. If you change one single node in the graph, then all downstream nodes should be re-executed. And so with these runbooks, we are equipping developers with a very powerful tool. It's unblocking reproducibility, allowing you to move with velocity and safety. So how does this work practically? When you start Surfpool, we are naively checking if you are in a Pinocchio-based project or Anchor project. When that's the case, we are scaffolding some infrastructure as code, allowing you to get your programs deployed. After review and validation, your programs are deployed on your local surfnet. In this scaffolding, we are retrieving the three categories of construct we touched on. The on-chain construct, the signing infrastructures, and finally the off-chain components. We'll get back to that. Then when you start Surfpool with the --wash argument, the infrastructure is being redeployed every time your programs are being recompiled. So with that, you have a very fast feedback loop. Next, let's look at the off-chain directives. In this program, we are emitting a CPI event. If you have such directives in your program, it's probably because you want to perform some sort of indexing at some point. So Surfpool is detecting these kind of patterns and pre-generating a construct which will send a subgraph specification to a data indexing engine embedded in Surfpool. This indexing engine is ingesting data from your SurfNet activity, exposing your data through a clean GraphQL API. None of the details are lost. We even generate the GraphQL docs using the Rust docs that you have in your program code. And so transactions emitting these events are indexed in real time, allowing you to build your front end locally with a clean GraphQL query endpoint. Last but not least, the signing infrastructure. So the first investment we received when we started Txtx back in July came from a company that lost millions due to a compromised private key. Security is in our DNA, and we believe we've designed the right framework. Iterating locally with an ephemeral key pair is perfectly fine, but upgrading to a safer signing setup should be seamless. So today we support three types of signers: hard-coded key pairs, connected web wallets, and multi-sig setup using Squad. Switching between them takes just a few lines of config. Additionally, runbooks support two execution modes. The first, that we call unsupervised mode, runs like any CLI script in your terminal. The second, on the other hand, is bringing the ability to control the execution of the workflow by launching a web UI, walking you through the workflow execution interactively. So this checklist UX adds context, requests confirmations, and turns the signing experience into a transparent and auditable process. It's worth noting that the runbook code stays the same. We are just switching the execution mode. And so we think that this supervised mode is a perfect guardrail, especially for introducing more secure signers. So if you want to use a web wallet with the supervised execution, all you need to do is change the signer in your config. Once that's done, your runbook will prompt for signatures at the right time, ensuring transactions are signed by the expected signer. It's also doing some checks, like ensuring you have enough funds and so on. And yeah, again, if you want to migrate to a more secure sign-up like a Squad, it's just a few lines of config. So Surfpool starts as a drop-in replacement for the Solana test validator, but within a project, it quickly becomes a force multiplier for both velocity and safety. So thank you for your attention. Check out the repo, Txtx Surfpool, star it, clone it, fix it. If you're curious about the subgraph hosting feature, say hi or DM me on X. And yeah, big thanks to Colosseum, Turbine, the Foundation for the continuous support. And wish you all a great conference and enjoy the rest of the workshops. Thank you.